a projectile motion? We said you must first read the statement. From the statement, then you now come up with the important information. The important information that was given to us is that now our projectile is rolling. After taking out the important information, what is it that we must do?
Draw a trajectory.
Draw a trajectory. Remember, a trajectory, it's now a sketch. A sketch that shows now the motion of the object. Again, it was thrown vertically upwards. So it then says to me, my projectile started at this point and then it was thrown vertically upwards. And then is caught at the same point. It says to me that my projectile went up and then it came and then it was caught at the same point from which it was rolled. So it means now if this is the motion, a trajectory will now show us the motion of the projectile. That it was thrown vertically upwards and then it was caught from the same point that it was thrown. Remember, without drawing the trajectory, you can't be able now to see the motion that the projectile took. Again, after drawing now your trajectory, then you build it. It started here. This will be my point A. And then it went up, point B. Then this now becomes my point B. And then comes back, and then this now becomes my point C. It means now, for an object that was thrown vertically upwards, its trajectory will have now 3 points. Point A is a point now where our projectile was thrown vertically upwards. And then point B there, it's a point now where our projectile then now changed direction. Again. And then at point C here, that's where now we caught our projectile.
So, can I see velocity
Incorrect. Incorrect.
It's less than V initial.
Is
Less than V initial.
it's less than V initial.
No, it's greater than the initial.
It's greater than V initial. Incorrect.
but it's a caught at the same point. So,
Caught at the same. It means now the velocity at C. It's the velocity that the projectile will now hit your hand. The same as the velocity at which a projectile hits the ground. Louder. At point C there, it's the velocity at which now the projectile will hit your hand. Correct. Very correct. After now drawing our trajectory, we then have to talk about each and every point. Each and how many points do we have? 3 points. We must then come and talk about each and every point. Each and every point. Let's start with point A. At point A, remember at point A, it was now a point where our projectile was. And we know that the word thrown tells us now that the V, I will not say V initial, you will see for what purpose, but I will keep it as velocity at A. I will keep it as velocity at A. I wouldn't want to commit myself to say V initial. I will keep it as velocity at A. I will explain it to you right now because there's going to be a point when we are solving this kind of a problem. We are always going to now consider 2 points. We are going to consider only 2 points. Either you will be working with point A and point B. If you are working with point A and point B, your point A will now become initial, and then your point B will now become your final. But when you are working with point B and point C, B now becomes your initial point, and then C now becomes your final. So it then depends on which points of the motion are you working with. That's why I don't start by committing myself to say V, this is the V initial, and then this is the V final. Because when I'm working with point B and point C, point B now becomes my initial. Then point C then becomes my final. So I don't want to commit myself as early as now. So I will then say velocity at A is greater than 0 meters per second. But there's a but. There's a but. There's a but. Our projectile is going vertically upwards. What do we know about velocity as the projectile now goes vertically upwards?
Decreases.
Velocity decreases. Then we'll say velocity at A is greater than 0. But it decreases. It decreases as the projectile approaches point B. Because our projectile is now projected vertically upwards. And we know that from our analogy, if a projectile is going vertically upwards, its velocity now keeps on decreasing by 9.8 meters per second. Then at point B, that is an important point of our trajectory. Remember we said Okay. At point B, this is the point now where now our projectile is going to change direction. Remember, from this point, from A to B, our projectile is going vertically upwards. And from point B to point C, our projectile is going vertically downwards. So tell me, what should happen at point B before the projectile changes direction?
Velocity must equals to 0.
The
Velocity.
velocity at point B. I'm talking about point B, okay? Then I'm saying VB must be equals to 0. Let's break it down. Before an object can begin to change direction, it must first stop. Before you can change direction, if you are walking eastwards, before you can change direction to go in the opposite direction, you first need to do what? To stop. Round one. Yes. So the velocity of our projectile at point B must then be equals to 0. Just so that our projectile is now able to do what? To change direction. At point B, and this point B of ours has now a beautiful name. Point B, which is the highest point, where now the object begins to change direction. We call this point the maximum height. You must know that at the maximum height, the velocity of our projectile will then be equals to 0. Because at the maximum height, it is a point where now our projectile will begin to do it, to change direction. Yes.
Because the acceleration of one mobility for object to move upwards. Right.
We have not chosen any direction as yet. Like that. We have not chosen any direction. We are now busy analyzing now our trajectory. However, now, at this specific point, what's happening? At point A, we know that the velocity is greater than 0. How do we know that? The statement. Because an object cannot now go up without being given a velocity which is greater than 0. For an object to go vertically upwards, it must now be given a velocity that is greater than 0. Okay. And then point B, we are saying our point B is our what? That's our maximum height, where our projectile is going to do what? To change direction. And before our projectile can change direction, it says to me, its velocity must now be equals to 0. Because remember, when the projectile was busy going upward, its velocity was decreasing. And then when it reaches point B, which is our maximum height, then its velocity was 0 meters per second. Maximum height is a point now where our projectile is going to change direction. And before our projectile can change direction, it must then come to a stop. Hence, we are saying that the velocity at point B is equals to 0 meters per second. Because when the object was going upwards, remember, its velocity was now decreasing at a constant velocity of 9 meters per second. And then when it reaches point B, which is our maximum height, then it will have a velocity of 0. And this maximum height of ours is very important, because in the exam, they will never tell you that at point B, that's where our projectile reaches maximum height, and then velocity is equals to 0. No. You must know that when our projectile reaches the maximum height at that point, its velocity is equals to 0. Remember, when we go now to the calculations, we always say now we need 3 variables. 2 are given easy. 1 is D. So if you are given a type 2 problem, where now you have a projectile thrown vertically upward and caught at the same point, you must know that where our projectile is going to change direction, that is your maximum height. And what is important about your maximum height? It's that its velocity is equals to 0. In the exam, they will never tell you that at maximum height, the velocity of our projectile is equals to 0. You must know that when the object is about to change direction, that point is the maximum height. And at maximum height, the velocity is equals to 0. That is one of our hidden variable, but it's no longer hidden.